In the latest issue of the journal Physical Review Letters, a team of astronomers reported the detection of a new kind of extremely low-frequency gravitational wave. This discovery has shocked the scientific community, and for good reason. You see, this wasn't just any old gravitational wave. No, this was the loudest sound ever recorded in space. And it's not even the first time either. You see, back in 2005, astronomers picked up a deep cosmic hum. This sound was coming from a supermassive black hole that's 250 million light-years away. The frequency was so low, you'd need 1 trillion ears to hear it. But the energy was immense. It was the loudest sound in the universe. To give you an idea of just how powerful this sound was, imagine 10 million supernovas exploding at once. That's the kind of cosmic music space is playing, and we're just beginning to listen. These incredibly low-frequency gravitational waves are produced by the movement of massive objects in space. They ripple through the fabric of the cosmos like a stone skipped across the surface of a pond. But unlike the familiar sound waves that travel through air and our ears detect them, gravitational waves are disturbances in the very structure of space-time itself. They stretch and squeeze the space between galaxies, carrying with them a wealth of information about the violent events that created them. The first detection of these waves was made in 2017 by the Laser Interferometer Gravitational Wave Observatory, or LIGO. Since then, scientists have been working to understand the sources of these signals. The 2017 event was thought to be the result of 2 neutron stars merging, but the newly discovered signal is different. It's much louder and lower in frequency, indicating that it came from something much more massive, a black hole with a mass greater than 10 billion suns. The detection of these low-frequency waves opens up a new window to the universe. It allows us to study phenomena that were previously beyond our detection capabilities. For example, we can now listen to the sounds of black holes as they devour matter and grow in size. We can also study the gravitational waves produced by the collision of galaxies, giving us an unprecedented view of these spectacular events. Moreover, the study of these waves provides a unique way to test our understanding of gravity. Einstein's theory of general relativity has been remarkably successful in explaining the behavior of gravity, but it's yet to be fully tested at low frequencies. These gravitational wave observations could help us to identify any deviations from Einstein's predictions, opening up new avenues in our quest to understand the nature of gravity. As we continue to develop more sensitive instruments, we'll be able to detect fainter and more distant sources, providing an ever deeper understanding of the universe and its evolution. Who knows what other secrets the universe is hiding? Perhaps there are sounds too low for us to hear, too high for us to perceive. But as we continue to explore the cosmos, we may just tune in to the symphony of the spheres and discover that the universe is a much noisier place than we ever imagined.